Welcome to Impact Physics. Today we are going to be learning about the half-life equation. We'll be deriving what? The equation. So I told you in the previous video that half-life is the time taken for a radioactive substance to be reduced by what? By half. So if you want to learn about the equation, how you can derive the equation, please watch this video to the end. And if you have not subscribed, do well to go to my YouTube channel and do what? And subscribe. So let's carry on. First of all, we need to talk about the rate law. The rate law tells you that a radioactive substance reduces over time. Just know that. But if you want me to state it, I will state it for you. And if I want to state it, it tells you that the rate of decay is highly proportional to the amount of radioactive substance present. So from here, all we need to do is to rearrange and integrate. So if I do that, I'll have the n over n equal to negative lambda what? dt. So if I integrate, I'll have limits. Here will be n to n naught. I will still integrate this. I'll have t and I'll have both 0. If I integrate this, I'm going to have ln. We're going to have ln n minus what? N naught equal to what? Negative lambda what? T, right? So if I apply the laws of log here, I'm going to have ln n over n naught equal to negative what? Lambda what? T. If I simplify and take the exponent of both sides, or I exponentiate both sides I mean to say of the equation, I'm going to have n equal to n naught, then exponent, we have negative lambda what? T. So this is our second equation, but this is not the equation we're looking for. So we'll now apply the definition of half-life. If we apply the definition of half-life, what it means is that n will be equal to n naught over 2, and t will be equal to what? T half. Look at this. So this equation will look like this. N naught over 2 is equal to n naught exponent negative what? Lambda what? T half. So if I simplify this, I'll be having 1 over 2 is equal to 1 over 2 is equal to what? Negative what? Lambda what? T what? T half, right? If I take the natural log of both sides, so ln this will give me negative 0.693, and ln this will give me negative T half. I took the natural log of both sides at this particular point. So now from here I'll make my T formula, T half. So my T half will be equal to 0.693, and like you're seeing the board, over lambda. Now this is what we are looking for. We have derived it. Now this lambda here you're seeing is called decay constant. Decay what? Constant. Yeah. So I have this equation. Let me call this equation what? 3. Now there are about 3 equations that you should be aware of, that you may be making use of. The first one is this rate law. Most times they write this equation like this. That equation 1, I just put it in a box. You write it this way: R is equal to negative lambda what? N. So this rate law, you should be aware of it. That's our equation 1. Then the second one is this other equation we derived. Then the last one is the half-life what? Equation. So you should be aware of all these what? Equations, because you are going to be using them to solve what? Problems. Please, if you have not subscribed, do well to go to my channel and subscribe, share, and also comment. Thank you very much for watching.